The idea of completing the square is very useful in math in all kinds of situations. For us, we're going to be looking at completing the square of a quadratic function. So if we're given a quadratic function of the form f of x is equal to a times x squared plus bx plus c, we can do a lot with this form, but some situations call for this other version over here, sometimes referred to as the vertex form. So how can I get from something expanded in this way to something a little more condensed down? The key to that, and this is where the name comes from, is to make a nice perfect square trinomial. We want to complete the squaring process so that I can factor out this nice perfect square of a binomial. And we've seen a perfect square trinomial in our basics section when we talked about factoring. So how are we going to start this process then? Well, we're going to concentrate on that squaring part. We want this somewhere in our function here. Let's talk a little more exactly what this means. In our vertex form over here, our goal that we're trying to get to, we have this letter a, and that's going to be a coefficient, some number in front of my squaring term. I have this h and these k values here. Now these are going to be constant, some sort of number, positive or negative. So again, the goal is to make that x minus h happen. Well, if we expand that x minus h, it's going to take the form of one of these two down here. These are the ones that we've seen in our last section. So if we expand an a plus b, multiply it out using our distributive property, the FOIL method, we'd end up with a squared plus 2 times ab plus b squared. So the key on this is that I have two of those middle terms. And my last term is that b value squared, this number squared. Then if I have a subtraction, again, that b value, once I multiply it all out, I would have 2a times b here. Of course, there's a minus in front, but there's still two of them. And that last term is that b value squared. If I replace the a value with an x, so that I have x plus b squared, it looks more like what we need it to be up here, then my expansion, when I multiply it all out, I would have x squared plus 2 times b times x. Remember that a is replaced with the x value, plus the b squared. And the same thing in the subtraction situation. I would have x squared minus 2 times b times x plus b squared. But even though we made that replacement, we still have 2 times that middle term. That middle term is repeated. And the b value, the second term here, is the one that's going to be squared at the end. So that's going to be our key pieces. We want to find this b value that's going to be doubled in the middle and squared at the end. Let's try it out. Example 1, we want to complete the square. Example 1, complete the square. Part A, we have f of x is equal to x squared plus 8x plus 15. So we can see how this is not in the correct form. It's not in that squared form there. And I want to make it into that form. That's the completing the square part. Well, to start, we're going to take our function and rewrite it. It's still f of x though. And I want to rewrite it with all of my variable parts, the terms that have a variable in them. I want to group them in a set of parentheses. So I'm going to group my x squared plus my 8x. I'm going to leave some space here, and then I'm going to put the 15 on the outside because it doesn't have an x on it, my variable. Then from this inner parentheses that we've created, we really haven't changed the function. We're just kind of spacing it apart a little bit more. But from the inside of the parentheses, I want to look to see, do they have any coefficients that I can factor out? Is there anything in common on the coefficient part that I can bring to the outside of the parentheses I created? Well, the x squared here, my coefficient is a 1. 1 and 8, I can really only factor out 1. So there's nothing really to do for that check, that part. There will be situations where there's a number, and we'll see those in a few examples here. But let's look at the basic one on this one. It's really nice because it's an x squared and 8x. We're done with that part. My second step, the second thing I want to do is I'm going to take this middle term here. Remember what we want it to be. That middle needs to be 2 times this b value that I'm looking for. I'm looking for that right b. So if 8 is equal to 2 times my b value, that means my b value, I'm going to take 8 and I'm going to divide it by 2. I'm cutting that term. This 8 has that 2 in it, so I want to figure out what is the b value on its own. So that b value is 4. So it looks like my magic b value is going to be 4. That's where I'm kind of thinking right now. But to make sure that that perfect square trinomial is going to happen, I need something at the end over here. We said that b value should be squared at the end to make it nice and factorable in this way. So once I have this b, I'm going to take my b value and I'm going to square it. So 4 squared gives me 16. And I don't have 16, I have, well, nothing in here, and I have the 15 on the outside. So here's where we do something a little bit, maybe a little bit tricky, but it's very useful in math. Here's what we're going to do with that 16. I'm going to add that 16 on the inside. So adding it on the inside makes this exactly what we want it to be, like our setup. But if I add 16, that means I'm changing the whole function, right? I can't just add numbers to a function and it's going to stay the same. That's not true. So if I'm adding 16 on the inside here, I'm going to subtract it on the outside. That keeps my function balanced and it doesn't actually change the value. So I said this was a little bit tricky because it's like introducing a special version of 0. What is 16 minus 16? Well, that's 0. It cancels away. But I need to see the 16. So I compensate for that with that subtraction on the outside. So it's a very useful thing we see a lot of times in math. We kind of forget about it sometimes, but it's really powerful when we need it. So that's nice. So back to our completing the square. We've kind of made it look a little bit messier than what it started with, but now we've set up that parentheses, that trinomial, so it's going to factor out exactly as we want it. So if I have x squared plus 8x plus 16, on the outside I can combine these. What's 15 minus 16? Well, that's -1. And if I look at my inner parts and I practice my factoring, I know that's a trinomial, so I can write it as a pair of binomials. I know x squared is going to be made with x times x. Then I look for two numbers multiplied to give me 16, but when I add them, I get an 8. So multiply to get 16, add to be 8. Well, that's 4 and 4. And they turn out to be exactly the same factors, x plus 4, x plus 4, because we built it that way. Remember, we're trying to get that squared part in there. So of course they're going to be the same if I've made it that way. So then my answer, my function in this new form, will be x plus 4 squared minus 1 on the outside. So we can see how it matches that form we wanted. Now another little nice thing. You may already see this and recognize it. Where did this 4 come from in our factoring? Well, remember we said this 4 is our b value. That piece of our factored form here is always going to match the b value. Remember, that's the number in the middle here divided by 2. It's always going to be that value. Let's try another one. Part B. We have f of x is equal to x squared plus 6x plus 3. So first step, I'm going to take my function and I'm going to group all of my variable parts, my variables together, leave a space, and throw my constant on the outside there. I look to see is there any coefficients I can factor out from the variables here, right? Not the actual variables, just the coefficients in front. Well, I have a 1 again and a 6, so nope, I can't do anything with that, so I'm good to go. Second thing, I need to find that special number that's going to make it all work. So I take the value in front of the x, always the number, not the x, just the number. And that number is 2 times that b I'm looking for. So the b value is 6 divided by 2 in this case. And you'll notice it's always going to be divided by 2 because we're always going to have think of this as double the value we need. So 6 divided by 2 will give me 3. So 3 looks to be what I'm going to end up using, but I need to square that to complete my trinomial here. So 3 squared is 9. So I'm going to add 9 on the inside, but that changes the function. So to compensate for that, I subtract the 9 on the outside. Then if I go with my factoring, if I have x squared plus 6x plus 9 minus 6, this subtracts to 6 there. And then I do the factoring of that trinomial I built. I get x times x gives me that x squared. Two numbers multiplied to give me 9, but add to be 6. Just as we expected it, it's that 3, right? That 3 that we say. And we still have that minus 6. So then here is my new form. These two functions, what I started with here and what I ended with, they work the exact same way. They end up giving us the same answer, right? But the operations are done in a different way. But it's still the same function.